Hello, hi, and welcome to today's Unity tutorial. We are going to add a game mechanic called controls. So from today on, we can actually control our player object. Let's get this started. So this is the status that we have. We have the little bean. The little bean has physics, right? The little bean has physics. So if we touch it and we can let it bounce, right? And that's going to be a game mechanic. Course. But that's it. We cannot control it. WASD doesn't work. We can't do anything with it. So in order to make something, to make it move, we need to give it behavior. Usually a behavior that we want to create is called a script. So some programming part. In order to be able to use scripts, you had, like in the first video, I showed you where to download and get Visual Studio, for example, an IDE we are using here. And you can make sure that it's actually working by going to Edit. Then there's Preferences, and in the General tab, no, in the External Tools tab, there should be Visual Studio selected up on top here. If you do not have it installed, you cannot select it. You can also have other tools. For example, you see I've got Visual Studio in 2 editions, 2019, 2017 in here. I'm using the 2017 one. It does not really matter. As long as you've got a script editor, that should be fine. If this is empty for you, just download one. Very good. And that is automatically linked to Unity. You don't have to link it there manually. It should have done that automatically. If not, do it manually. So we want to add a behavior to our player. Just simple controls. Therefore, what we want to do is we are going to add a component, and there, whoops, we can select off many things, right? On the rear bottom here, right behind me, on the bottom here, we can add a new script. Let's give that script a name. Let's call that player movement. Not just player movement. You can give it a name, whatever you want, whatever standard you want to find for yourself. Player movement, hit enter, and it's creating it. You will see that it was automatically added to your assets. So you can drag and drop it to any other object. For example, if you want the plane to move like the player, you can just add it there, which of course you don't want to. So right click, remove the component from the plane. We only need it on the player. Good. As soon as you double click on it, as you double click on it on the movement script, you right click properties. Now you have to double click or double click down here. That's the same thing. It will open your programming editor. In this case, I have got this one here, which is Visual Studio. Visual Studio. If you've got any other will open. The first thing that you will see is on top, automatically these 3 lines have been added. Those lines using indicates it is using already some pre-made functions. Using system collection generic, those are always added because they are a collection of standardized tools that you might use in programming. In our case, we don't need them, so it is okay if you just delete those 2 lines. Perfectly fine. You can also keep them. Doesn't make much of a difference. I like to delete them because I don't need them anyway. The next line is using Unity Engine. That means we are able to put a lot of Unity-specific programming functions into our script here. That includes working with the rigid body, with the physical component that we use for the player controls. That also includes shooting, that includes jumping, that includes a lot of things, right? Everything that is Unity specific. So we need that, we need to have that in here. Then we have 2 things added from the beginning. We've got a void start function. This function is executed when the object actually shows up in the game, only once, right in the beginning, right at the start when the object shows up. Then we've got the update function. The update function is a standard function that is executed every time the game loads a new frame. So if your game runs with 60 FPS, it is 60 times per second. If it runs with 10 FPS, it is 10 times per second. So it is just uploaded every frame of the game, right? We will need this one definitely, and the start one is also usually used. Those are the standard functions that are mostly used in most objects. Okay, good. Control S, if you hit Control S, you are saving the script and it is automatically saved then in your Unity project. So what do we actually need to do? So what we want to do is on top class. Class is the whole script that we have. Everything that is written now in player movement. So everything that is in this little component that is right there. That is why we open the bracket here. What do we want to work with in this component? We want to push the player around. That's why we need to import a rigid body component, and especially a rigid body component, the one that we've got here. We want to import to our script so we can work with it. So there's two ways of doing it. I will show you both. The first way of doing it is making it a public component by writing public. Then what type of component do we want? And because we are using the Unity engine, we can just write rigid body. Now Unity and the script here knows, oh, you want to use a rigid body object. Of course, a rigid body component. Yes, please. That's only possible if you use the Unity engine. If you don't use it, you cannot write rigid body here. It won't recognize it as a correct thing. So if I get rid of this, you see this changed the color and now it's broken kind of. So we're using the Unity engine here. This rigid body also needs a name, and there's different types of spelling, right? There's different types of casing. In our case, I'm going to use this type where we start with a small letter for a variable and then I go rigid. And then if we start the next word, we're going with a big letter. Rigid body player. And we hit off with a semicolon because that's how C# works. This is C# scripting, by the way. Yeah. So this is the rigid body of the player. If I now save, either on top here or Control S, you will see Unity is now loading. There was a little load icon, and as soon as I select the player, you see the player movement here now asks for rigid body player, which is now big uppercase with some spaces in there, because Unity knows, you're using that special type of case, which is camel case, I think. Yeah, I think it's camel casing. So it recognizes we're using that standard. That's okay. And you see it says none in the end. In our script, which rigid body do we want to work with? I want to work with this one. So what you can do is just drag and drop that on the rigid body here. And now, whenever in the program, whenever we use this rigid body component, we're actually looking at this one here. That's the first method. That's a good one. That's a good method. The second way of doing this is the following, which is in the end easier, but you're losing a bit of an overview. The second way is not this one here. If you type 2 slashes, that makes this line a comment, which will not be executed as a code. We'll leave that here. And I will say, I will also give this a statement here in the end, public rigid body as example. I want to use a private component that is also a rigid body. And I will give that the same name, because I can use the same name because now I don't use the upper method anymore. So it's overwritten here. Rigid body player. And now I can take this and go here in the start statement. So I'm doing this once in the beginning. I can tell the program actually to load that component, which is rigid body player, is the same as. So in the beginning, please load get component, right? Get a component, and get component means it looks at the script and it looks on top here and on the bottom. So everything that is connected to the game object, it will get one of those components and of the following type, rigid body. You have to close this with brackets and with a semicolon. So this will now automatically load the rigid body component into the script. Right? So that's easier to use. So when I save and I go back to my Unity editor, you will see that it disappeared from here because it's not public anymore. It's just private. It's inside the function, so we don't see it. Okay, that's good. So that's what we're going to use. Right? I want to have a second public variable. Right? A second public variable, a public float. Float is just a comma value, like with a comma, like 3.7 or something. And that I want to be the movement speed, because I want to change that later on. So if I go back to my Unity editor, you can see we've got movement speed here now, and it's at 0. Let's put it to some number, at 10, for example. We can just change that on the go. So that's the first thing. The second thing is here in our update function now. We actually want to add controls. Hey, that's why we're here. So very quick, we want to add controls. And the first thing for controls is we want to have an if statement. And if we are pressing a button, right? If we're pressing a button, that is through the so-called input method. That is again from the Unity engine. We have an input method. If input dot get key, right? Get key. With this, we are actually asking for a keyboard key if it is being pressed. There's also get key pressed, get key down. Whoops, get key down, and get key up. I think so. Doesn't matter. We're getting a key on the keyboard, right? And then open bracket again. We need to put a key code in. Key code dot, and now we choose a letter. Now we choose actually a button from the keyboard. Alpha are the 1, 2, 3, 4, 5, and you see all the buttons are here. I want to have an A. Closing brackets, and that's the if statement. So if we are pressing, if the input that the game detects is a key and that key is button A, then we're going to do something. What we're going to do is in opening those brackets, so which is Alt Shift, depends on your keyboard. In German keyboard, it is somewhere on, it's on the A7 actually. Those brackets mean that everything in here belongs to the if. So if this here is true, which will be asked every cycle of the game, every frame of the game, then something is going to happen. So what is going to happen? The first thing I want to have is a debug. Debug is just a message for you as a programmer. Debug, open bracket, and let's say left. Whoops. Let's say left. Debug.log, that's the message for the programmer. Whoops. So whenever you hit the A key, you're actually displaying left for the programmer. Only, not later on in the game, but just for the programmer. The second thing we want to do is actually with the rigid body, so the rigid body that we have created earlier, copy and paste the name here. For this rigid body, what we want to do is we want to add a force. So the physics, the control system that we have is really physics-based. So it's like pushing the player, or that the player model actually moves on its own using force. It's really force guided. We're going to use that mechanic more and more in the game actually. So we're going to add a force. And which force are we going to add? In this case, it's actually pretty simple. We're going to add a force into a direction vector 3. Vector 3 is a 3-dimensional vector. In our case, it's this one here. Right? It's exactly that move vector that we have here, where up is the green arrow up, down is the green arrow down, right is the red arrow right, left is the red arrow left, and forward is the blue arrow forward, back is the blue arrow to us. Right? And we can use that. We can use that, and we can just say vector 3 dot left. That's to the left. Right? Vector 3 dot left times our movement speed that we have imported here on the top, that we have created, which we can change in the game and in the editor. Very simple, very easy. And unfortunately, there's one more thing. Times, and that one is complex. Time dot delta time. Time dot delta time does the following. It actually is doing a calculation. This update function is called every frame. Every frame, between the frames, there's a different time depending on your PC speed. Some PCs have a very short time between frames because they're very fast. Some PCs have a very large time between frames. So that time we have to consider, and that time is exactly time delta time. So it doesn't matter if your PC is slow or if it's fast or if it's somehow laggy. The controls will always be the same speed for us as the player, right? So that makes a lot of sense. That's why we have to add time delta time, comma, and we just in force we have to say what type of force, what force mode do we have. We want to make it an impulse. An impulse means we're pushing the character, right? And that's it. Closing it with a semicolon here, and that is the controls for left. So if I save now, I minimize this, and I can now directly start the game. Right? And if everything was done properly, we can actually go to the left. Did you see that? Let's repeat this. Let's repeat. We can actually go to the left when I press A. The thing is, our character, we're pushing force, right? We're pushing it with force, so of course the character falls over. One thing that we need to change, because it's physics-based. The rigid body here has so-called constraints, and we have to freeze the rotation so it doesn't tip over. So which rotations do we freeze? Right now it fell over this way, which is around the z-axis, the blue one here. So we have to freeze the blue one. So freeze rotation, the blue one, the z. We also don't want to tilt it over to us, so I also want to freeze the x rotation. Right? And now if I hit play again, we should be able to go to the left. The problem is right now it's not strong enough. We should freeze rotation to the left. Yeah, that's okay. I've got the movement speed. Let me see if I did something else wrong. I did not. Freeze rotation, that's okay. You see, sometimes even I am struggling. What? Freeze position, that would not make sense. Freeze rotation would make sense because we want to freeze the rotation around the z-axis so it doesn't fall anymore. Okay, did I change something else by chance? Plane has the material. Oh yes, that is my bad, because right now the character already reacts on the physics properties of the floor. When testing I actually changed that. I added some friction. Right now the character also reacts on friction, because hey, that makes sense. We're pushing it, but if the friction on the ground is too high, it won't move. And now with no friction, it can actually move to the left. If you want to have it a slower movement, of course, you can increase the frictions here depending on what you want. That was a little bit too much already. That now works together with the physics system, with the controls here. Whoopsie, sorry. This you can use as a game mechanic to slow down your character. So we're going to have different grounds depending on the friction, higher and lower. The character will stop more, will start slower, and that kind of stuff. For now, I want to turn off the friction. I am sorry, I forgot that I added it. Yeah. Okay, let's go on. Let's make this a 20-minute video. 20 minutes I can do. We saw the debug. Whenever I hit A, you can actually see the debug down here, very important, in the console. Right? If I hit A, you see I pressed left. You can also see it's actually all the time. It is now 400 times already. It's while I press the button down. Every single frame, this has a new entry. Okay, let's add the controls for the other dimensions here. Very quick, right? So you can just grab all of this, right mouse button copy, or just Control C. And what I want to do is hit Control V or paste, right mouse click paste or Control V. And I want to have left, I want D should be going right, and that is not left, that is right. Copy, paste. Then I have W, that is forward, which is along the world axis forward here. That is forward. And I want to have the next, which is S, which is back. And that is back. Right. Control S, I'm saving this. I can go back to my game. And now we have something that we can already play around with a little bit. We're going to add one more feature in a second. Whoops, I only froze the one axis. Whoops, I have to freeze the X axis as well. And now we can already move around, right? And I can make the speed slower, right? I can make the speed faster just by dragging and dropping this little line here. Whoops, that's yeah, that's a little bit too much. 10 is a nice value here. Last thing I want to add, let's make this a 22-minute video, sorry. The last thing I want to add is jumping mechanism, right? Jumping mechanism by doing the following. Again, copy this, paste it here. Key code in this case now will be space. So when we hit the space button, right, space key, we're going to jump. And that will be the following, not back, not front, not left, not right, but up, right? Up. And that is now pretty much it. The only thing that I want to change here as well is I want to introduce a new variable, public float jump force. And we can already say how much it should be here on top. I can still change it later on. 5.0 F for float number. Jump force, I can just Control C, Control V here instead of the movement speed. Now the only problem that we will have is that it gets evaluated all the time, right? So when I hit the space key, we will be jump, but you will see it will be like, it will be a rocket. Whoops. Because the jump was probably too low. Yeah, there we go. It's basically a rocket, which is not correct. So what I want to do is also to not do it permanent, because as long as I press the space button, it does that. It adds more force, so it's permanently pushing up. Jumping is just once, right? So I want to have not get key, but get key down, only when you press the button down. And also we don't need the time delta time now, because we do it manually, right? One by one by one by one. Control S, looking at the game again. We can now change the parameters, but it should be a nice little jump and a nice little bounce when we hit the ground. And we can already run around, jump a little bit, play with the parameters so I can increase the jump force. And now I'm jumping a bit higher. Where am I? There. Boing. I can, yeah, let's maybe 4 is okay. I can change the movement speed. We can also change the on the plane here, we can change the material if you want more bounciness, for example. I can test that out. Now it's bouncier. You can play around a little bit with those parameters. This has been a 20-minute video, 22 minutes. I am sorry for this. So we're cutting it at 22 minutes. Thank you for watching. This is the basics of the controls here. There is another, this is now physics-based controlled. There is, maybe you will see it at some point, there is something called a character controller here. That one is a not physics-based one. We are using physics-based controls. That one is also a lot of times used, but not what we are doing. We are doing physics-based controls. This is not physics-based controlled. So we are not using that one. It helps a lot, but we are just not using it right now. So the last thing for preparation for the next time, we don't need the debugs anymore. So let's get rid of the debugs, because I don't need them anymore. Control S, saving our progress that we have. Going back to the face cam. Now it's 23 minutes. Thank you for watching. I hope this is any helpful. We already have a playable game now. We can move around, we can jump, we can play around a little bit. We need to improve a lot of things. Play around with the parameters a little bit. Let me know if it works for you in the comments below. Leave a like, don't forget to subscribe, and I am going to see you. I will see you in the next episode. Thank you for watching, and bye-bye. Bye.